Hi guys, welcome to Unit 3, Lesson 6. You've probably noticed we skipped over the last two lessons. That's okay, we dropped the discussion and stuff, so you don't need to worry about those two lessons, 4 and 5. But let's get into it. Unit 3, Lesson 6, Scale Drawings. Alright, so scale drawings are a type of dilation, especially when it comes to drawings, right? Think like a building, right? When they build or when you've probably heard of like blueprints, right? That's a scale drawing, meaning everything is to scale, meaning all of those angles are the same, all of the side lengths are proportional, stuff like that. It's just shrunk down, right? Or even think about like a model car, right? A model car is like a scale drawing, or like if you were to draw a car, right? That would be a scale drawing of a much larger object. So, as a reminder, dilation is the increase or decrease in the size of a shape. Scale factor is the ratio between the size of a dilation of an object and its original size. Okay? So let's go straight into our first example. Here's number 1. We've got 4 different drawings. We've got a star, triangle, right? And each of them have a scale factor, okay? And within that scale factor, we need to determine which scale drawing is a dilation that decreased the size of the original object it represents, okay? So I put a hint down here, scale factor. It's a ratio, which means we can write it as a fraction. That's how I chose to write it here. So the size, and maybe I should have written it as like using the colon, like the ones in that in number 1 show. So we could say size of dilation and then size of original object. Okay, so in these ratios up next to these shapes, we need to pay attention to the numbers. So we're looking for the one that decreases, right? So that's like where the original is bigger than the dilation. So bigger number, smaller number, right? If the size is decreasing. So that would be like a car, right? And then doing a drawing based on that car. So we're looking for a larger number to a smaller number, okay? So we got to kind of think backwards from what you would think that you need to. So, and you might notice right away that there's only one of those where the second number is bigger than the first. This means that the dilation was 1, original was 5, so it went down. All of the other ones, maybe you'll notice that they're, like for the octagon, it gets bigger, right? It went from 0.5 up to 2. For the pentagon, 0.1 up to 1. For the triangle, 1 all the way up to 10. So in this case, this would be your answer, okay? So the wording is a little funky on it, but hopefully this information right here makes it a little more manageable. For our next example, if you want to dilate a square with a side of 6 units to create a square with a side of 18 units, what scale factor should you use? So we want to go from 6 to 18, okay? So our scale factor, we just need to think to ourselves, well, what can I multiply 6 by to get to 18? 3. So we would use a scale factor of 3. And that's it. That's your final answer. Okay? And number 4 on the quick check. Our third example, which is number 4 on your quick check. If you use a scale factor of 1/5 to create a circle with the radius 18 centimeters, what is the radius of the original circle you dilated? So with that, you might freak out for a second because of the fraction, but it's really not that bad, okay? So really what we could do is we could say 18 is 1/5 of the original. Okay? So if we do that, then we could kind of translate it into equation. We could say, okay, 18, we know what 18 is, that's another word for equals, 1/5, and then of always means to multiply, and then we could say the original, okay? Or C for circle, or whatever you want to put there. Well, all right, that's good to know, because now that it's an equation, we can go ahead and solve. Well, if I'm multiplying by 1/5, in order to get rid of that, I can divide by 1/5, if you remember from solving equations. But if you divide by 1/5, that's the same thing as multiplying by the reciprocal, right? So there's a lot of things coming back into this one little equation. So with that, we can multiply by the reciprocal, which is you flip the fraction, right? So whatever you do to one side of an equation, you have to do to the other. When you multiply reciprocals together, they equal 1. They cancel each other out, right? Because 5 over 5, right? Because 1 times 5 is 5. 5 times 1 is 5. 5 over 5 equals 1. So they've canceled each other out, and we're just left with the original. And now we just need to do 5 over 1 times 18, which is really just 5 times 18, which is equal to 90. So the original circle had, oh, I guess we could have used R for radius when I was building my equation, but the original radius would have been 90 centimeters. Okay, so I hope that helps. These are a little bit more abstract concepts than what we've been talking about. So if you need anything, let me know.